Okay, this video is going to look into solving an absolute value inequality, and what I'm going to do is kind of show you a couple things that are going to get you through all of the solving absolute value inequality type of problems that Alex can throw at you. So the first thing that I'm going to do before I even give you an example is explain a couple of things. First, if I told you the absolute value of a number is supposed to be, like, let's just say less than 4. Think about this visually. Basically, if I have 0 here and then 1, 2, 3, 4, I think you would agree that x, whatever's in the absolute value, would have to be something smaller than 4. So I'd have an open circle on the 4, and I can pick any number between 0 and 4, but just not 4. So all possible solutions so far would be in here. But because this is an absolute value, I could actually go as far as -4, right? So like if I went out up to -4 but didn't include -4, all of these absolute values would also satisfy this inequality. Like -3, for example, if I took its absolute value, is +3, which is less than 4. My answer would look like this. It's kind of a compound and inequality that looks like that. If, on the other hand, I said the absolute value of x had to be greater than 4, all right, that would be a little different story. Here, I'd have to pick all numbers whose absolute value is bigger than 4. So I'm just going to kind of cut to 4. That would mean I couldn't use 4, so it would be an open circle, but I'd have to use something larger than 4 to be a solution, like 7 or something. The absolute value of 7 is bigger than 4 for sure. And all other distances bigger than 4 would be over here. But I'd also be able to choose x values that are less than -4 over here. All of the numbers that are over here also have a distance that is greater than 4 units away from the origin. So there's kind of a cool thing going on here. When you have an absolute value inequality, your graphs are actually compound and or inequalities. And I have a little trick for you to remember which is which. You see the sign here? A lot of you will call that a less than sign. That is less than. I agree, that's a less than sign, but the way I want you to think about it when you see an absolute value that's got a less than sign, think of this as a less sandwich. And the reason why I say that is because if it's less than, you can say less than which, because it ends up making a compound and inequality, which sandwiches all the values between like a small value and a large value and just shade in between. So all absolute value equations that have this less than or less sandwich sign will end up looking like this bar. Okay, so you need to kind of put that together. Now, I also have a trick for this inequality, which you would probably call a greater than sign, right? That's a greater than sign, but I don't want you to think of it like a greater than anymore. I want you to think great or than sign. The reason why great or, because we're using the word or, and an or inequality looks like this, right? Where you have the graph opening in opposite directions with a gap, right? So if you can remember the less sandwich sign and a great or sign, you're going to be in really good shape. Let me show you an example that Alex will throw at you. And I'm going to go right to the more sophisticated ones because I think you can handle following it along. Let's say I gave you the absolute value of 2w minus 9 is greater than 5. Now, I misspoke. Yeah, that's a greater than sign, but I'm thinking great or than sign. So to set up a great or, all you have to do is this. Rewrite this and just drop the absolute value. So it's 2w minus 9 greater than 5, or it could be the inside 2w minus 9. Then you have to switch the sign and switch the sign on the number. So that was key. You have to switch the sign on the inequality and on the number, right? So let me maybe put arrows going here too. So the first one, just drop the absolute value and write it down. No problem. Easy peasy lemon squeezy. The second one, drop the absolute value, switch the sign, switch the sign. Greater than becomes less than, 5 became negative 5. Solve each of these. Now we should be on easy street. Solve each of these separately. I'm going to add 9, right? That's going to give me 2w greater than 14. Then I'm going to divide everything by a 2, which will end up giving me w greater than 7, right? Done with that guy. On this one, I'm going to also add 9 and divide by 2, but it's going to give me a little different answer. I get 2w less than, what is that? 9 minus 5 is 4. Dividing by 2, we'll end up with w is less than 2. So my final answer, if I had to graph this in Alex, if this is 2 and this is 7, I'm greater than 7, so open on 7 and shading to the right. I'm less than 2, open and shade to the left. And notice it follows that OR compound inequality kind of a pattern. That would be my answer. Now, just to show you the other possibility here, example 2, I'm going to make almost the same. Let's say I had 2w minus 9 in the absolute value, but instead I have it less than, or I'm going to make it equal to 5. Now this is no longer a great OR sign, this is a less than which. Less than which. So when you set up a less than which, all you have to do is this, copy down the inequality, 2w minus 9 less than or equal to 5, right? I just copied it down, but then I want you to do this. Copy that sign over, so it's another less than or equal to sign, but then over here, switch the sign and make it between negative 5 and 5. So you have to put the opposite of that number to start it off, and then just copy down the signs and copy down the original inequality, and you can solve this compound and inequality like so. I'm going to add 9 everywhere. So negative 5 plus 9 would be 4, less than or equal to 2w in the middle, less than or equal to 14. Then I divide everything by 2. So I get 2 less than or equal to w, less than or equal to 7. That's my answer. And notice when you graph this, it's a sandwich between 2 and 7. I want all w's, or all numbers that are greater than or equal to 2, so it can be a filled in on a 2. But also less than or equal to 7, so filled in on 7 and going like that. And there's my sandwich between 2 and 7. That's how absolute value inequalities work. Thanks for watching, and good luck.